The next speaker for this session is Justin, Commercial Engineering Director, Industrial Cybersecurity Lead, APAC, Belden. His 20-year career progressively spans industrial controls and automation, engineering services through to business development and technical management. He works with clients to deliver industrial networking solutions that are fit for purpose and address critical aspects of availability, integrity, maintainability, scalability, and cybersecurity. He delivers pragmatic and functional cybersecurity solutions, bridging the gap between OT and IT. He holds a bachelor's degree in engineering, electrical and electronics with honors. He has achieved Cisco CCNA 2004, Hirschman HINE 2010 certifications, and is currently pursuing his CISSP certification. Please welcome Justin.
Everyone, thank you for that. It's a hard time to be presenting. So I'm going to be sharing with you some thoughts around industrial cybersecurity. So hopefully that's going to be something interesting that you can take away, something very useful that you can use immediately in your organizations. This is an interesting area. So let me just start going. I'm just going to jump straight into this. You've seen a lot of talk about the technology today. Great presentations. You can see the amount of solutions and the amount of integration that you can get. Big data mining, whatever you want to call it, digital dashboards, shop floor to top floor integration, real-time decision making. The only communications technology that's going to connect that is IP. You're not going to pull Profibus from your plant floor all the way up to the C-level suite. You're using a lot of open-based technologies, Windows, Ethernet, and that's going to create certain issues. So the first thing basically is you can see the benefits, but then again, how many of you actually have legacy installations? You have brownfields. You will not always have a greenfield to install. So you do have to think about how you're going to actually have the legacy coexistence between the older and the newer equipment, and also bridging the gap between IT and OT. And with all of this, you're going to get a higher exposure to security risks. I like Mr. Sivaram's presentation earlier from AIA, and he mentioned a really interesting thing. You see all the technology that's available. One of the biggest gaps to make all this a reality, and I was just at an event as well in Singapore a couple of days ago, which was on a similar topic. And the biggest gaps are going to be skills and procedures and processes, because that's going to make or break the technology. Cybersecurity, just last year alone, there was over 1 million unfulfilled roles globally. Okay? And when you talk to C-level suite people and organizations, there's a high amount of them, 74% will tell you it's not a matter of if they're going to get an incident or a breach, it's a matter of when. There's been a 50% compounded annual growth rates specifically for industrial cybersecurity incidents and attacks between 2010 to 2015. Interestingly enough though, if you look at the statistics, 85% of them could have been blocked, stopped, or remediated by basic remediations which just were not used. And another scary thing is though, the average TTD, or the time to detect, when you do actually have an incident or a breach, can vary anywhere between 200 to 365 days. So you could have an incident, someone's machine in your organization has a virus and you won't know it's there. 200 days, the TTD. So when you look at industrial cybersecurity by itself, we always think about cybersecurity as the bad people, hackers. It's not a wrong place to start. But think about it this way as well as you move towards this Industry 4.0 and IoT. The first thing you realize is that a lot of the attacks and threat vectors are mostly automated. It's not a hacker sitting there anymore trying to get into your site. They craft certain things like malwares. And we'll go through some very interesting case studies afterwards. These things are automated. They propagate by themselves. There's also something that our industry actually believes, and it's called security by obscurity. We think that nobody knows how to hack a PLC, nobody knows the vulnerabilities to do with this particular product, or that remote I/O, or that motor drive that we are using. The information is freely available. And I'll take you to a quick website later on. There's a screen capture of that. More importantly, a lot of the tools that you can get today for what the industry calls as script kiddies, very basic people who just know how to do a couple of command line attacks, they are freely available. And a lot of these things, I do encourage you to come by to our booth later on. We will demonstrate live attacks to you. Live attacks, spoofing, tampering, repudiation, information disclosure. We do have a live demo in our booth, so I do encourage you to come and spend some time with me and my team. Now, when I talk about information disclosure, if you haven't seen the ICS CERT website, this has got a list of common vulnerabilities, and I do suggest if you're not on this, get on the mailing list. You see some very, very common names up there. And when you look at these names, they're very, very big companies, very, very powerful industrial automation companies. Does this mean that these products are bad? It does not. This tells you one thing. Every product that you have out there has its vulnerability. Whether or not it has been discovered and whether or not it can be exploited are two different things. But this information is freely available. Just go to the website, have a look at that. One of our problems in automation, which I'll go through a historical trend afterwards, is the fact that we've always ignored security. Our protocols that we use has always been designed for low latency, for performance, for real time. It's never been around security. If you try to make a communication protocol secure, you wrap something around it, like encryption. That creates latency. Latency is typically never acceptable if you need real-time performance. And we'll go through some different consequences between IT and OT in the next couple of slides as well. So let's have a look at a list of documented industrial security incidents over the last 7 years. And we always think about it that it is a hacker. So that if you can't read that, basically it's an entire pie chart, and 20% of the attacks are intentional. That's where the hacker sits. And 80% of documented attacks isn't a hacker. Interesting. Within the 20%, 47% of that is the hacker. So it's the smaller of the smaller amount. So who else is doing this intentionally to you? You've got more to worry about your disgruntled employees. Employees over time in your organization, which has been there for the last 10 to 20 years, do they have what we call in industry as privilege creep, privilege escalation? That means throughout their role, they've had multiple passwords, authorizations to do things. Every time they change roles, have those authorizations for access been revoked and new ones been given, suitable for their new role. So we're not talking about technology here. There's no firewalls that I'm talking about, even though I want to sell you one. Give me some ideas of what you can think about. So who are the rest in that 80%? Human error. How many times have you had people install things on your site, plugged it in, and brought the network down? Malware infection. Malware isn't a malicious attack. It's an accidental one. I'm sure you all heard Petya. I'm sure you all heard about WannaCry, the recent ransomware. I'm sure you even read about some of the organizations that it hit. These were big organizations. You can't say that they had no cybersecurity initiatives and no protection. So we need to be asking ourselves, how did it propagate so quickly through these organizations? Are we investing in the wrong areas? Are we buying the wrong technology? What is missing? Okay? Malware infection. Third one, of course, we do need to think about is software and device flaws. These things actually do create issues. Okay? So the thing that you've got to think about now is that it's not only about confidentiality. You need to think about integrity and availability. So confidentiality is how you actually secure a piece of information, that when you actually allow someone to access a resource, you need to be able to identify, authenticate, authorize, and do your audit and accountability. Integrity means that when your information is in rest, or when your information is in motion or in transit, it doesn't remain, there's no chance of it being tampered. It maintains its integrity. And there's something that all of us here, as we from the automation field, are very, very familiar with: availability. 24/7 operations. This is what the field of industrial cybersecurity is about. I'm sure you all know the Stuxnet. Hands up, how many of you heard of the Stuxnet worm? Couple people, excellent. I'm from Australia. I personally like the Stuxnet worm for one very good reason. Before the Stuxnet worm came out, every cybersecurity event you attended, especially the ones that talk about industrial control systems, talks about one case study. It was a case study that happened in Queensland where a disgruntled employee of a system integrator hacked into a water treatment facility that they were working on. He emptied raw sewage to the car park into the river, and that was always the case study that everyone talked about until Stuxnet came about. Because Stuxnet is actually a very, very interesting malware. So we're going to deep dive into this. We know that it was actually designed to go after Natanz, the Iranian nuclear centrifuge project. There is also talk that it's obviously a very heavily sponsored nation-state attack. That means there was sufficient funding behind it. And when you look at how it actually propagates, let's deep dive into it. So we know the name Stuxnet. The project was rumored to be called Olympic Games. It was called Stuxnet because when the original people who analyzed the code, there was the word Stux and the word net, and that's how the name got coined. It was an interesting move because Natanz was air-gapped, and a lot of us believe an air gap works. The threat vector was a USB stick, which wasn't dropped into the site. It was dropped into 5 of the system integrators that were doing work in Natanz. It took a while before the virus made it into Natanz. And if you actually look at, you Google, you can find an actual map globally that shows where the Stuxnet virus went to. It went all the way down to Australia. It propagated for 9 months, but it didn't do anything on other systems because it was very, very specific. What do I mean by very, very specific? Let's look at the code details. First thing was that it was very dense. Compared to your standard malware code, it's about 20 times the size of it. It was very purposeful. They knew it was very professionally written. Okay? A zero-day exploit is a method to actually infect a system that has never been detected before. So it's very effective. Reason why signature-based detections never work, like an antivirus, is because of zero-day. If you're using a signature, you need to know that this is bad before you block it. But if you don't know that it's bad, you don't know what you don't know, you allow it through. Stuxnet went in equipped not with one threat vector, that's a zero-day. It went in with 4. On average, if you go to the dark net, one zero-day threat vector can cost you anywhere between $100,000 to $150,000. For $500,000 just on that. How it got onto a Windows system was it actually had 2 valid digital certificates stolen from a technology park in Taiwan. And it used those to actually hop onto Windows-based systems. Now, when it hopped on, it was fully self-sufficient. It did nothing for 13 days. It did nothing for 13 days because that was the average amount of time it would take to fill the 200 over array of nuclear centrifuges with enriched uranium gas. And during that time, it recorded normal operating parameters, of which during the attack, it would replay back onto your SCADA screen so that you would think that you were in normal operations. It does 2 things to frequency drives that was specific for the Siemens PC7 system that was attached to it. Basically, one to speed it up, one to slow it down. Both of which basically create instability in the nuclear centrifuge and created physical damage. So you look at all of this, it's interesting. It's something that attack a PLC. It comes by via USB stick. That's not my biggest takeaway. My biggest takeaway on something like that is the fact that for the first time ever, the bridge between the cyber and physical system has never been more dangerous. This is akin to me telling you that I could send you an email and someone could die. Information security and cybersecurity in the industrial world is very, very different. Let's look at a couple of other threats, especially around industrial controls and automation. Saudi Aramco, Shamoon, didn't attack the actual industrial area. It had 3 components. We suspected it was an insider job. It wiped out 30,000 workstations. Went for the master boot record, wham, 30,000 workstations wiped. Good thing it didn't actually hop across from the enterprise to the industrial world. Dragonfly. Dragonfly is an interesting one. The first incident was Stuxnet was to disrupt the process. Shamoon disrupt the business. I personally never thought after all these years that anyone would steal information from industrial control systems. I came from the industrial world. When you sniff packets on an industrial network, it's ones and zeros. It's not even the PLC code. That's in the engineering workstation. Dragonfly, for the first time, until today, nobody actually knows the actual details, but we know that it actually infected components that were used in pharmaceuticals. It was a multi-phase attack and multi-campaign attack. And when it came to pharmacy, it didn't do any damage to the actual processes of the sites that it infected. So a lot of people were thinking, and the experts postulate, that this was actually, for the first time, intellectual property theft for pharmaceuticals. Okay? And the recent one at the Ukraine power grid. Just in December last year, we know that they had a massive blackout. The threat vector of this was very old school. It came in via somebody opening a Word attachment in an email, and the Word attachment had a macro virus. I've not seen a macro virus since the 90s. But what it did was give the actual attacker access to the Windows domain server, which he got the username and passwords. And then it did two things. It actually then downloaded into the serial to Ethernet converters that allows this HMI station to get remote access to the substations with a corrupted firmware. So that was in the standby memory. The operators basically said someone took control of the HMI. The mouse started moving by itself. They couldn't lock them out. Breakers started tripping. And once they finished the remote trip of all these breakers, they rebooted the serial to Ethernet converters. And because the firmwares were corrupted, every serial to Ethernet converter became bricks. People had to drive out to site to manually reclose the breakers. I think there's a lot of people who live in Ukraine because apparently they got it back up in hours, but they had to manually reclose that. The third attack was actually a master boot record attack on the Windows machines for the HMI. Very, very crafted, very, very real. So now when we think about all of this, and I'm spreading doom and gloom, the good thing though is that if you've got a structured and very pragmatic approach to this, there are ways to protect your organization and to make it safe, or as safe as it can possibly be. One thing that you have to be very honest yourself is look at your organizations, and if you need to answer the question, what is your current security posture today? What are you compliant to, or what are you not? Are you following any standards? Every organization follows this cybersecurity path not as a destination. It is not a firewall. It is not an antivirus software. It is a journey that contains about 8 disciplines, which I'll go through later on. But how to figure out where you are on this journey, I would typically tend to ask, do you have a proper risk assessment? A risk assessment that details very clearly what your threats, your vulnerabilities, and your consequences are. Because if you have that, it gives you the capability to decide where you're going to be spending your money. Because if you're spending it in the wrong area, that could be a potential waste of resources. So do you have a risk assessment? If you completed one, you're putting some controls in place, and if you're very mature, you're usually fine-tuning these controls, going back to it on a regular basis or as threats or as incidents and breaches occur. Key takeaway, they are not technical solutions. Your cybersecurity program needs to have C-suite support. They're more economic and strategic more than they're actually technical, if you really want this to work. And why do I call it a journey? Just like what we talk about viruses, etc., it's like your human body. If you want to stay healthy for the rest of your life, you do have to make sure you eat well and you exercise. You don't exercise till you're 10 years old and you're healthy. You don't install a firewall and you're protected. And just because you exercise and you're healthy or you got a firewall, does it mean that you will not fall sick? Of course you will. What it means is that you're able to recover faster in the event of an incident or a breach. So it has to be a journey. Okay. Now, if you've ever worked and brought IT and OT people in the room together, it's fun times. And here is why. There's a key fundamental difference in the perspectives. So the 3 things I talked about earlier: confidentiality, integrity, and availability. And you ask the IT guy, what's the most important thing? They're all important. No. If you could let go of one a bit more than the other, which one could you not live with and which one could you have a little bit more leeway on? And what tends to happen is when they talk about it, they'll say this: confidentiality is the most important thing, integrity, And then they'll say, no, but my data center and my systems, I've got a RAID 10. My data center's N+1. I've got 99.999% availability. The OT people don't like that because that is not operational availability, that's design availability. How many times have your IT department sent you an email that says, this weekend, from Sunday, 12 midnight to 6 a.m., we are shutting down this server to do some upgrades and patches. Imagine you doing that every week on your OT systems and your automation systems. No go. So what's happened is when you speak to an OT person, it's the other way around. But because they've put 24/7 availability first, confidentiality has fallen all the way down the bottom. And this is the reason why OT people sometimes aren't capable to understand the importance of that. And you know what? Both parties are correct. And both parties actually need improvement. If you ever run into any issues and you bring a team together, the best companies I've worked with that I know have good programs actually have a team that's called I&OT. They finally decided that cybersecurity for these things isn't IT's responsibility, neither is a joint effort. That's called C-level or C-suite sponsorship. Okay? Because if you wanted to summarize this, one of them thinks about protecting the data and the other one protects the process. Are they both right? Absolutely. Okay. So if you think about why we've not focused in the OT world, historically, let's take a quick look at it. So we've always believed in things like there's an air gap. And over the years, we started to use more open systems, Windows. We started to use Ethernet infrastructure. And then one day we've decided we're going to connect the shop floor to the top floor. And I'm going to put a firewall over there, and that's going to make everything okay in a DMZ as well. How many of you have contractors and system integrators and operators coming in to do maintenance work on these new systems that you've installed because they require a different set of skills for maintenance? Let's say that was the contractor, and over here, he is the threat. The vulnerability could be a malware that he's carrying on his laptop that you've allowed him to plug into your network, and the consequences are denial of service on your network. So let's have a look at how this threat vector propagates. Step through it. Bad contractor. It's got a malware on his machine. They've plugged into your network. First thing the malware does is it does a denial of service on the Ethernet network, clogs up the network so that things can't communicate effectively. There's vulnerabilities on the Windows machine, and it spreads, just like WannaCry, using the SMB. And it does attack on the secondary Ethernet card on the other station. That does a denial of service again. It won't spread any further than that because these are not Windows-based. But you know what? He's not hacking the PLC, but this is good enough to drop comms on your control and your device network. What about the other way? What if it's a human error, not an accidental malware, and there was a critical component that was configured incorrectly that was storming the network? If it's not configured correctly, it will still also cause a denial of service in the network, and any item that's connected onto it will then lose communications. Right? So where do you start? When you want to think about a logical thought process, what frameworks are you using? Any good framework typically will have a combination of these 8 elements. Are there any ISC Squared certified or SANS certified people in the crowd? If you're not, I do suggest, if you want to get into the field of cybersecurity, ISC Squared and SANS are great organizations to study on and work with because they have good certifications that will take you on this journey very effectively. Now, when you think about cybersecurity, it's made of 8 disciplines which ISC Squared have put into their CBK, or the Common Body of Knowledge. And if you look at that, what we do as Belden, we do a big part, communication and network security. But operationally, you do need to think about different things. We don't do training and awareness. Someone needs to teach your organization and make them able to recognize how an email may look malicious. How, for example, if they see a USB stick in your car park, they don't accidentally pick it up, walk past your security, walk past your data center with your advanced next generation firewall, and plug it into their machine. Social engineering things, they need to be able to identify this, tailgaters. So there's a lot of different disciplines when you look at what you need to think about. I can't go through all of them right now, but if you want to spend a bit more time in the booth, I can go through them there. But think about this from a holistic perspective, because any good standard will have this. It will have a combination of technology, people, and processes. So when you look at NERC, which is probably the only, I think, global standard that wields a stick. It wields a stick because if you're in non-compliance in North America, in the industry of power transmission, generation, and distribution, and you don't comply to these segments of what they call the SIP segments, they impose a legal fine. They wield a very powerful stick, which then helps to make the industry better in power generation, transmission, distribution in North America. So when you look at these things, the combination of technology, obviously technology, so there comms, ports and services, patch management, you see things like training and awareness, disaster recovery, that's a key part. Disaster recovery forms a key part of cybersecurity. When you have an incident and a breach and you lose information or a resource, how do you get your first responders to bring that system back up? Who are your first responders? Where's the backup hardware located? Where's the software located? Where was the last backup for this piece of information? Right? And when you look from a practical perspective, they've given us an indication about where most of these corporations have failed. So one of the highest ones, the top violations were on the technology side as well, in the assets and the management of the assets. Because if you cannot see and you cannot tell me what you have on site right now, you cannot protect it. You cannot protect what you cannot see. And obviously there's a couple more on the rest. Training is the next highest one. Physical security, right? If you don't have a standard in your country, or it's being built up, do you wait until it's ready? Or do you have something to fall back on? If you don't have one and you want one to use, IEC 62443 is probably one of the best ones you're going to find. It is a cybersecurity standard specifically for industrial automation and control systems, and it also has a combination of people, processes, and technology. Okay? I'll zoom into one particular one, which has to do with networks, zones, and conduits, and we'll go back to that case study around the networks and look at how we deploy something like that. So obviously you can see over here there's a general, there's policies and procedures. This is more the technology side, which is what Belden can actually help you with a lot, especially around the network and communication security. How you identify and break down your threats. Your risk is quantified as your threat, which is the intent and the capability, multiplied by the vulnerability of the system, multiplied by the consequence. Why do I say this very clearly? Because when you look at this big elephant around cybersecurity, people worry. They go, that there's so many things that could happen, and that could happen. Where do I start? Where do I spend my money? And you get analysis paralysis. Just like fire. If you got fire, you need three things: heat, oxygen, and fuel. If you need to put out the fire, you don't need to remove all three. To reduce your risk, you also don't need to remove all three. If you can reduce your threat, you reduce your vulnerability by patching, or reduce your consequence by making sure that if someone hacks into it, there's nothing happens. You don't lose any money, you don't lose any availability. Your risk goes down. So what you want to try to get to is an output that looks like this when you go through that process. The threat vector, vulnerability and consequence, and if that entry point of the threat was deliberately accessed and accidentally, then you decide whether you want to do the mitigation and what it comes down to, which is your residual risk. And that's a very important thing, because this tells you your C-suite and your organization's risk appetite. Sometimes when you come to this stage, the organization can also make a decision to say, I accept the risk. Most people think, if I've got a risk, I need to solve it, I need to bridge it. That's not necessarily the case. What if you had a pharmaceutical system that was running Windows XP? You know you can't do much about that unless you stop and replace everything. That could take time and money. They make an educated risk while they plan for the migration. They put what they call a compensating control next to the XP machine. At one point in time, I heard that even the pharmaceutical sector, some of them actually put aside ransom in their budget because they were prepared to get hit. And the organization made a conscious decision based on the risk assessment that they would pay, because paying was cheaper than upgrading the system at this point in time. So think about it, not that if I've got a problem, I need to put a firewall, I need to fix it. You need a risk assessment, because this tells you where you should be spending your money. Okay? So zones and conduits, very quickly to go through it before we wrap up. Now, the idea about a control system and 62443 zones and conduits is to basically split them up into logical zones. And every chance that a zone communicates to the other, you want to ensure that only the minimal amount of traffic can go through between these trusted zones. This creates a defense-in-depth environment. Defense-in-depth isn't just about multiple layers, which most people think it is. It's multiple layers, but differentiated threat protection mechanisms. Because that means that if someone compromises one mechanism, the other mechanism isn't the same, and it slows them down. And it contains the threat, hopefully soon enough for you to be alerted and alarmed to respond. Okay? Sometimes there are more threat-specific ones as well. Okay? In a summary, it's the right technology, could be an appliance, could be a software, at the right location in the network. So let's go back very quickly to that same scenario. Let's build up some samples for zones. Okay? And let's have a look at the conduits where they communicate, for example, and let's put some protection mechanisms over there. That could be a firewall, that could be a switch mechanism, that could be anything that allows you to detect and deny and protect that particular conduit. Same scenario, let's go through that same thing again. Contractor has a malware. You've allowed that person to come in. Nothing's going to stop that. The denial of service attack is going to work. You will lose comms on that network. But now, because you've got a defense in depth on a zero-day issue, you are able to contain it. Because everything still stays up, it can't spread, and you alert and alarm into a security incident and event management tool, a SIEM. Likewise, if it was the same misconfiguration down the bottom, this will still block that conduit, and everything still stays up. And once again, never forget to alarm. So this is how the concept of defense in depth truly works with zones and conduits. Now, you can think about it from the networking perspective as what we do. Everything that Belden does covers the layer 1 to layer 7, all the way from threat detection to the most basic stuff. We do cables. We're the only company in the world that actually can secure your 7 layers under one banner because of the companies that we've actually acquired over the year. How do you use cable, for example, as a security? Think about it as human error. What if someone was tired at the end of the day and you told them to disconnect port number 3 of a switch and all the cables were blue? Changing a cable to red could potentially reduce that human error. As they pull that and go, oh, red is the control system or the safety shutdown system connected to the HEMA or the Triconics. And it slows them down. Everything you can do to delay this helps you. You can secure it not even with a firewall, with a good switch and good software, with a firewall, and with good threat detection systems for change. So just a quick one to wrap up about us as Belden. We're actually a cable company, as most of you would be familiar with. Over the last 10 years, we went on a very interesting and very fruitful migration into a signal transmission company, whereby we decided how we're going to be able to not only make the cables, but how we're going to transmit a signal from point A to point B reliably and securely through the products that we've got. Our 1, 2, 3 approach when we're talking about securing the network is pretty simple. Protect your network, protect your endpoints, protect your controllers. Key takeaways, they are real, the threats. It's a journey. Use a risk assessment to prioritize your spending, all right? Use recognized standards and frameworks. Think about the AIC and CIA. Bring your I and OT teams together. It's not just about technology. I hope you buy a Belden product, but remember, it's also about people and processes to make this work. Get C-level sponsorship. Please, please manage your networks. Everything that you talked about today needs a network. That will be the weakest link if it's not designed and deployed correctly. Use Defense in Depth and 62443. And that's basically going to wrap everything I've got. Thank you very much. Hope it was useful.